freue mich, Herrn Martin Bujnák vorstellen zu dürfen. Er beschäftigt oder wird sich in den nächsten 15 bis 20 Minuten uns das Thema 3D Reconstruction, Fast and Accurate, the New Era of 3D Scanning präsentieren.
Thank you. Okay, today I will be speaking about creating 3D models from photos, in particular photogrammetry. Yes. And you may already have experiences with it, and you may know it as taking a small object. So it's a small object, taking few pictures. You need expensive software, expensive hardware. You will be waiting hours in order to get a 3D model, and you will also spend hours on post-processing. So this is completely done from photos, and it's a smaller object. But how about making a little more challenging photogrammetry? Using thousands of photos and no small camera. Use a big camera, 80 megapixels, 30 megapixels, and so on. And you want to, how to say that? You want to add some constraint. You don't want to spend lifetime waiting for result. You want to use your ordinary computer, so you want faster processing. So you are looking at a model, which is pure photogrammetry, so purely created from photos. It's about 3,000, maybe 5,000 photos, I don't know, without post-processing. And you can see many, many small details. You will see a small close-up in a minute. And so that explains why you need to take thousands of photos in order to create 3D model like this. And this is model completely done without post-processing, any post-processing. It's from the project of cultural heritage, which was done in Slovakia. So our customer couldn't modify 3D models at all. So this is purely as it came out from our software. And you want to have this kind of 3D models in hours, not waiting days or months. Yes, it's golden. But actually, since it's very old, there are many tiny scratches, and if you have a high-resolution camera, then you can basically see those scratches, and then photogrammetry methods may work. Okay, so let's make it even more difficult, and let's shift to, say, 100,000 photos. And big photos. Let's add laser scans, and you still want to be young and beauty when the model processing is finished, so you want to spend years on processing. And this is the model. What you are looking at, those tiny dots, actually are pyramids, which are showing camera pose and orientation. And you may say that 100,000 images is too many. But let's look at the size of the model, the scale. It's a huge cathedral. So now, in context of this cathedral, the 100,000 photos is not so many. And those photos, we are talking about big photos, like 80 megapixel photos from air, 30 megapixels photo from ground. So because you want to capture whole cathedral, say in 1, 2, 3, 5 millimeter detail, depending on the structure. So this is a sparse model. It means there's not a mesh in the full detail. It's a sparse model. Camera poses, so you can see the scale of the building, how big is it, how many cameras are there, and so on. And let's have a look at the model. So we just pick a little part of the building because it starts to be like huge. You can imagine 100,000 80 megapixels photo is terabytes of data. So let's take a little part of the building, and let's look at the one tiny part of it, and let's calculate the 3D mesh of that. So this is it. So you can see even lighting conductors. So this is the detail which you can do today easily. Just taking pictures. Here are some laser scans as well. But just by taking pictures, you can create models like that. Okay, let's open just the tiny part of the model and see it as a mesh in the mesh lab. And it's just this tiny rectangle. And the whole cathedral is actually created in such a huge detail. So this is possible today. And this is actually reality capture. This is the software, made in software, which we are developing. And this is what is possible today. You can take pictures and create models of such a detail, such details. And some small ad. It's a wizard music, but this is what you may see on the internet. Music. Thank you. Yeah. So this is reality capture, and the question is, why we are unique? What is difference comparing to what you have seen before? And the thing is that we did a huge shift in technology. And our algorithms are linear in time complexity, meaning that linear in time or in count of photos. So that's a huge step. We can do unlimited level of detail on a limited hardware. It means that you can process the object of size of the cathedral on the single machine. And also we can mix many type of inputs, like combine lasers, photos, structure light, and so on. And at the same time, we created the world's fastest and the most accurate, we call it a game-changing technology since, because look at that. We are 13 to 46 times faster comparing to any competition on the market. So you can see, so it was measured on 3,000 photo data set. And just to show what does it mean to be 13 to 46 times faster, imagine what does it mean to be 10 times faster. You can imagine to stay without water one day. But in 10 days, you would be dead. So that's the difference between 10x. Or you can imagine what does it mean traveling by bus 1 hour instead of 10 hours. And you can imagine the difference if you are getting 1,000 euro per month or 10,000 euro per month. So this is just to show the scale. But what does it mean 10x? So let me show a practical case. What 10x speed up brings you? It allows you to focus on your work. So if you want to create a 3D model, you don't need to care about if I have enough fast computer. You just take pictures and let the software to do its job. Capture every detail, just take photos, and you got it. You can 3D print this. That should be nice. 10x means that you can reduce expenses by 70%. And why? That's actually feedback from our customers. And it is because you are fast enough so that you can create 3D models directly in the field. So if you are creating the 3D model of something and you can evaluate the model right in the field, you don't need to go back and forth and capture data which are missing. You simply do it. You can either calculate the full 3D model, or you can investigate whether you captured everything you are interested in, and then you can return home and calculate the big models, and that's it. So if you are not familiar how complicated it is to create a 3D model, this is a small video which will show it. So basically, you just take pictures, load it in application, and click a button. It will automatically calculate camera poses just from image information. Then you calculate the 3D model, and we've got several tools from which you can use to remove trees and things which you don't want to have there. We've got several tools for correcting geometry, and then you can also calculate the texture. So it's as easy as you saw. Reality capture offers also command line automation. So basically, if you want to process thousands of models, you can use a command line and feed the application with command line arguments, and it will process all data in batch processing. And another option is what we call reality capture engine. It is for seamless integration of our technology into your products. It means you need a C++ developer for that, and we've got very nice samples which will help you to embed our technology in your application. Okay, some wrong slide, but this is This is basically to show, actually, we are a young company, 2 years on the market, but we are worldwide known. And mostly now in the game and movie market. And we've got many friends around the world which are either using our software or embedding our technology in their products. And here I will show what does it mean embedding. Imagine you are creating your own application like a 3D printer, and you want to also provide a scanning interface for the 3D printer. Then basically you can use our technology and embed it into your solution seamlessly. Like here, this is seamless integration of our technology in Houdini, which is a 3D modeling environment from SideFX. As you saw in the previous video, this is basically the same. They add images, they created a node in their application which creates 3D mesh from photos using our technology. Seamlessly, completely seamlessly integrated in their solution. And then you can basically benefit from the tool chain they already have in their application. So if you need to do some post-processing, or you have your own algorithms which you need to use to produce some result, then basically you can use it. Because you get full access to geometry, textures, colors, and everything. And that's it. So in this particular example, a 3D scanner is used to create mesh, to create simplified mesh, and the Houdini toolchain is used to create textures, normal maps, simplified objects, and all basically, actually, you can use the delighting tools to produce an even better texture. And that's it. So, ladies and gentlemen, this is reality capture. And here is my assistant. And if you're interested in trying our software, come to her, and she has many redeem codes so that you can try it for free. No problem. Thank you very much.
Thank you very much, Mr. Bujnák. Pretty impressive animations and films. Are there any questions?
Yeah, one question about the light situation when taking the photos. I know, like, as far as I know, I thought that's a bit of an issue when you take the photos that you want to use in photogrammetry. That, like, if you have like hard light and hard shadows, that then...
Yeah, and that's the thing. Since we are so fast, you can basically take so many pictures. Actually, how it works, for photogrammetry, in order to work, you need texture on object. And if there are specular highlights, or if there is no texture, if the object is mirroring or highly reflecting, then basically you are not able to do that. And I use the golden sledge, in that example, because it is object of that type, where it's perfectly shiny. But the good thing about the mirror is that if you change the point of view, then basically the reflected object or reflection is smooth. So if you take enough photos, you are not always, but you are able to recover the original surface. And this is also with light. So you can change exposition, but you have to take more photos.
Another question?
Yeah, so Manfred from Botspot. So that was looking impressive, but the software looks so powerful, and today it's free, I heard. But what's the normal license model behind that? So do I pay 10 million euros for one scanner, or how does it work?
Okay, I will tell you a secret. Currently, if you go on our webpage, we've got like several licensing options, which are like pretty expensive. If you want a perpetual license and use laser scans and so on. If you want just photogrammetry, then we have a cheaper version. And if you want to use automation, then you have to. It's well 7,000 per year or 7,500, something like that. But then it allows processing laser scans, photos, and so on. So it might look expensive for if you are starting your businesses. Next, what we have, this is basically done with the SDK. If you use some particular industrial application, which is limited, and you are not processing cathedrals, because even taking scan of a cathedral, you will be very well paid to do that. So then the price of the license is reasonable. But if you are doing a smaller business, then we can have a better price for you. And also, actually, we announced it already. We've got also a very new licensing model, which we called pay per input. And it means that you are not buying software at all. You are using it freely. And you are buying a license for particular image. And let me explain it on an example. For example, you take 100 photos. You buy a license for those photos. Once you get a license, that particular license is saying what you can do with the photo. And the license says you can use it in our software for reconstructing 3D model. So you just load those images with the licenses to our software, and if you got a license, it will process freely the photo. If you don't have a license, it will ask, once the model is completely done and you can see and you are happy with that, you can look at the model and you see, okay, I'm happy with the model, let's buy licenses for images. And you may be asking, why buying licenses for images? Why not buying a model? And that's the clever thing. If you're buying a model, what if you find later that you are not happy with the model? You need to redo it, do some changes to that. Would you be willing to pay again for the changed model? Not. With our software, you can buy a license for inputs, which means that you can recreate any derivation, any simplified model, any textured model, anything from the photos where you already have licenses and any time in the future. So it means if you are not happy with the model and you did some changes in our software to get even better result, you don't pay next time. So basically, you are buying licenses and you own them. You own rights for processing your data. And you get the software completely for free. So this brings something like, it's not a pay-as-you-go, but basically because you own it for the rest of your life. At any time, you can also give those licenses to your friends, and they can use our software for free to create 3D models on their machines using your photos. And that's it.
Wow. Okay, but that sounds like you're a big company in Silicon Valley having 500 employees, and you're ruled by Google, or what is reality capture reality?
That's a good question. Actually, we are a small company situated in the Europe, in Bratislava, in Slovakia. So, just across a border a little bit. And no, we are developing this technology. Actually, the whole product came up from our own research and PhD and academia and so on. At some point, we invented something, and we want to share it with everybody. And basically, we are a small company, and we are thinking how to use this technology for everybody in the industry. So we are not a Google. We want to be the size of the Google because we have still many ideas which can help you, or help basically to bring automation into the process and clever algorithms. And we want to grow, but it's difficult to grow so quickly.
Thank you very much.
Thank you.
Are there any questions? One last? No? Again? Bujnák, thank you very much for your presentation.
Very much.